Alright, students, we're here to talk about the triangle proportionality theorem. This is section 8.6, and here it is. So zoom in. Okay, here we go. So obviously you can read the book. What I'm trying to do is help you out interpret what the hell this means. Okay, so what we have here is, it says, if a line parallel to one side of a triangle intersects the other two sides, then it divides the two sides proportionally. Now here's the thing. This information over here, I think actually, for some people makes it easier, okay? This is the same information without having to write out all this gibberish. All right, so TU parallel to QS, that's what that says. It's saying if the two lines are parallel, and then we get this fractions, like, oh no. All this is saying they're proportional. That's what proportional means. It means if you set up the fraction. Now, you're like, well, why would we do that then? What it's saying is, if you know these are parallel, then you can find out the lengths of these sides based on that. They have a relationship that's proportional. And the converse of that means that if they're proportional, then you know they're parallel. So forward says, if they're parallel, then it's proportional. Converse says, if it's proportional, then it's parallel. Okay, and converse and the regular is kind of like saying, if it's raining, then I take my umbrella, and the converse of that would be, if I take my umbrella, then it's raining. That's all a converse is. It doesn't have to be a math thing. It's just reversing your two conditions. Okay, so seen that before. I just want to refresh your memory on it. So I'm going to make a quick sketch, and we'll start solving some numbers with this, because that's what it's all about. All right, so here's my triangle. Okay, I'm just going to make up some random letters: X, T, K. X, T, K. And what we're going to do is we can draw a side parallel to any of the other sides, but let's say, the way it's facing, I'm going to draw a parallel this way. Try to make it look just sort of like it's parallel. So this side's parallel to this side. So let's go call this M, Z. So what the theorem says is if KT is parallel to MZ, that's what they were saying when they put KT parallel to MZ. That's what that means. Okay. Well, how would this be useful? Well, a couple things before we go into how it's useful. Why this works is you have a smaller triangle inside and a bigger triangle outside. The whole thing is because these are parallel, this angle is the same as that because they're corresponding angles. Okay, and that works if these are parallel. And we put these two arrows to show they're parallel. The two arrows mean they're parallel. And this angle then is the same as this angle. And we put these two dashes, the two little arcs to sort of show that those two angles are congruent. And because of that, you can show that if we cut out the other triangle, these two would be similar triangles. Because what they have is angle, angle, angle similarity. That's called angle, angle, angle. Well, where's the third angle? Well, this one angle is congruent to one angle, second angle is congruent to the second angle, and since they overlap, x is the same for all of them, so that would be the third angle. So if you drew this out, you'd have a big triangle and a littler triangle, a little bit more proportional than that. And KT x would be the same as MZ x. I could draw those better, but that's the idea. The two triangles would be overlapping. So you can scale it up. It's 100% what we did with dilations. So we already did dilations when we were enlarging stuff on Desmos. That's what this is. Now, the other thing we're going to do, though, really when we're not doing Desmos and stuff, what we want to try and figure out is what's the side length. So let's say this is 12 and this is 9. This is 5 and this is x. What the heck? Now, I know you're going to look at that and say, oh my gosh, how do we do this? Which one's related? That's what we got to figure out. So it said it divides the sides proportionally. So which ones do you match up? Well, let's take a look at this side. The proportionality of the side, this piece to this piece, because they're both on the same side. So when we write that relationship, we're going to say 12 is to 5 as this piece is to this piece. 9 is to x. All right. The key thing when you're doing that is to, if you want this one first and then that one on the bottom, this one has to go first and this one on the bottom. What I mean is if we went reversed, x over 9 would, as long as we do 5 over 12, if we flip-flop them, they're both the same. Okay? Either one of these works. And if you don't believe me, We'll solve it one way, and I'll leave it to you to try the other way, and you should get the same answer. Now, does it make a difference? No, honestly, it does not. Now, some people don't like the x in the bottom. Some people prefer to have x on top. It works out exactly the same in the end. So, the whole point of this is proportionality is the one time when you get to use cross multiplication. If a fraction equals a fraction, there's a rule that says the cross products are equal. X times 12 will be 12x, and 5 times 9 is 45. I'm going to switch pens here. Now, we're trying to get x alone, so divide both sides by 12. X equals 45 over 12, or approximately 3.75. In fact, this one divides nicely. It doesn't continue. You only need that approximately if you're rounding off. Okay, so that's what it is. That's how you can solve triangles. Now, all the setups are going to be the same like that. The only thing that gets different is they might have like an x plus 3 to make it tricky on you. If you do that, just put this as parentheses, but the rest of the rules are exactly the same. You set it up as parentheses x plus 3 down here. Okay, or this is 12x. Same thing. They would have a 12x on here. So that's the only way it gets more. They throw more x's in there, but the relationship's the same. This over this equals this over this. I like to say big part to small part equals big part to small part. The main thing you don't want to do is like, oh, 12 to this and this to this. No, these are two parts of the same side. These are two parts of the same side. That's why it's proportional. There you go. If you've got questions, email me, and we'll talk about it when we meet up next. All right, thanks for watching.